Hi everyone, my name is Prince Lamoth. I'm 13 years old and I'm in 8th grade. And today we're continuing our periodic table lesson with episode 3. And this lesson we're going to take a closer look at the names of the periodic table in their groups, as well as we're going to take a closer look in more detail of the SPDF blocks on the periodic table. So let's get started. Before we start talking about our S block, we need to talk a little bit about orbitals. Orbitals are just like the areas of space around the nucleus where the electrons are usually found. Now let's talk about the S block. The S block usually includes elements where the valence electrons are filling up the S orbitals. S orbitals are usually in a sphere-like shape, and the S block also includes the alkali metals, alkaline earth metals, along with hydrogen and helium. Next up, we have the p block. The p block consists of the elements where the valence electrons are filling in the p orbitals. Now, the p orbitals have similar to a dumbbell type shape or like a water drop type shape, and it also includes the groups 13 all the way to 18, except for helium, because helium is in the s block. Coming up now, we have the d block. Now, the d block consists of transition metals where the valence electrons are filling d orbitals. Now, the d orbitals have a little complex shape, somewhat like a lucky clover, but I'll throw up a picture right here. And now the d block elements are found in groups 3 all the way to group 12. The last block we have is the F block, and the F block includes the lanthanides and the actinides, where the valence electrons are filling out the F orbitals. And the F orbitals also have a complex shape. I'll show you it right here. And the F block elements are located at the bottom of the periodic table, where you can see like the lanthanoid and actinoid series. Starting off with the alkali metals. The reason that these are called the alkali metals is because they have extreme alkaline solution properties, which means that when they interact with water, they turn it into an alkaline solution. Similar to the alkali metals, the alkaline earth metals also contain alkaline properties, and they have the ability to make oxides and hydroxides. Next, we have the transition metals, and these are called the transition metals because they're part of the transition blocks, where they are also part of the D block right here, as well as the F block, which is right at the bottom 2 rows. Then after that, we have the metalloids right here. And the reason they have the name of metalloids is because they contain properties of both metals and nonmetals, which means they're not fully metals, but they're not fully nonmetals, so they're known as the metalloids. Following the metalloids, we have one that's pretty self-explanatory, which is the nonmetals. And obviously, the reason that they're called nonmetals is because they're not metals. And they also have properties that are completely opposite to the properties of metals. For example, they're really brittle and they're really bad conductors of heat and electricity. Next up, we have the noble gases. And the reason that these elements are known as the noble gases is because they're considered to have to be non-reactive, which granted them the name of noble gases. Then we have the lanthanoids and actinoids, and these two were actually named after the first element in their group. For example, the lanthanoids were named after lanthanum, and the actinoids were named after actinum.